Yeah, again, welcome to the EclipseStore fundamental training. Let me get directly to the information. This training will be recorded, as I said before, and you will get access after. Let me introduce myself a little bit. So I'm Kuemmel. I'm senior Java developer, I would say, part of MicroStream from the beginning. And yeah, I'm into customer projects and project manager, but I'm also let's say the how to say this? The project manager of the MicroStream cluster development stuff and so on. So, and of course, I'm trainer, and that's why I'm here, conference speaker. And I think Marcus will introduce itself after me. So let's have a look to the timetable. We started at 5, and the training is till 9 o'clock. And we have a little break, something between 6:30 and 6:45, but it depends a little bit on the topic where we are. So that means the break could move a little bit, but we have we have 5 hours. And yeah, let's get into some further information. As we said, training is recorded. You will get access, and you will also get access to all the code repositories of all the demo projects we work on. Question that's really important. Ask as many questions as you can. So there is enough time to answer each single question, and it's important that you understand how MicroStream basically works and how EclipseStore basically works, and yeah, that's important. The links from now on. So there is all that GitHub repositories are available for EclipseStore. Then we have our Eclipse documentation. Give me just a second. I will share the links also in the chat. So this is the link to the EclipseStore documentation. So it is that link. That's the documentation. And yeah, as I said, there are 2 most important repositories. One is mine for the training, and the second one is, of course, the EclipseStore, repository, and of course the MicroStream GitHub repository. Just a second, where you can find all the examples that you need to handle EclipseStore. Okay, let's move on. After the training, you will get a certificate. That means all of you are part of the training. We will add your email address to a specific list within our MicroStream cloud backend, I would say. And after the training, or a few days after the training, you will be able to download your certificate of that training in that cloud backend or in that cloud front end. So just register with the same email address at the end, and then you can get your certificate. If there are any problems with the certificate, just let me know, write me a short email, and I can have a look into this. But you have to register with the same email address you took part here at the training, and then you will get a certificate at the end when you join the MicroStream cloud application. Okay, let's jump into the topics for today. We start with 45 minutes EclipseStore introduction by Marcus. So that means after the topics, I will hand over to Marcus, and then Marcus start to the EclipseStore theoretical introduction. And then it's time for you to lean back a little bit and just look at a quick demonstration how to use EclipseStore and MicroStream. And that's it. Then we do together a step-by-step configuration. That means you will be able to code along with me. So that means I will share you a project, then you can enter that project to your IDE, and then you can code along with me through the whole step-by-step configuration demonstration. Then we will talk about all the different CRUD operations, so create, read, update, and so on, all the basic database stuff. Then I think it's important for you to know something about how to create a proper data model, especially with EclipseStore. It's a little bit different to the data models you are used to have, especially with relational databases. And I think that's a good point to show you what are the real differences between the two structures and what are the biggest advantages on EclipseStore and especially on the data model. Then we have to talk about queries. That's also a quite interesting question. All the time people ask how to get the data out of EclipseStore, how to stream the data. And I think Java Streams API is quite interesting, and we jump into that a little bit. Then we have to talk about lazy loading. So as you all know, that EclipseStore is an in-memory database, but that doesn't mean that all the data has to be in memory. Some of the data could stay on the hard disk, and for that we need lazy loading. And last but not least, maybe it's interesting for you how to migrate from MicroStream to EclipseStore. But yeah, most of you already knew this. There are barely no differences between both frameworks, and I think it's not big effort to migrate from MicroStream to EclipseStore. Okay, that's all from my side. So now I think it's time to hand over to Marcus. Marcus, are you ready?
Of course.
Okay, then.
Thank you. Thank you, Christian. Christian, you have to allow me to share my screen, please.
Okay. Okay, so.
Hello, everyone. Thank you for joining. It's great that you join us today. During our EclipseStore fundamentals training. So this is all about EclipseStore, the open source project, and we are very excited to announce that now the version 1.2 is available. It's the second update we provide, and so please write in the comments into the chat if you're new to EclipseStore. So this is an introduction to the fundamental principle, the functional principle of EclipseStore. And if you have any questions or doubts, please use the chat, or you can also use your microphone and interrupt me, so I'm pretty sure that we can answer all of your questions tonight. So EclipseStore is so we call it database-less data processing. It enables you to process data with pure Java without the need of using a traditional database system. Why should you do that? So there are great benefits. So queries are up to 1000x faster in comparison to a traditional database, and you will save up to 96% database costs in the cloud, infrastructure costs in the cloud, and in addition to that, it's even more simple to implement EclipseStore in comparison to a traditional database or NoSQL database. So 3 great benefits, and I will introduce you today how this works. So EclipseStore in a nutshell is a Java native micro persistence layer. So we call it Java native because it's pure Java. There is no other database specific technology used. It's the persistence layer that runs within your Java application or Java microservice. It runs in the same JVM as your Java process. It enables you to store any object, any Java object, any object graph of any size and any complexity. You can store the whole object graph, but mostly you will store individual subgraphs. So only changes are stored regularly to disk. And it's stored in a binary format into any data storage, into any binary data storage. So you can choose your storage target freely. And vice versa, EclipseStore allows you to load any subgraph, any object reference dynamically from the storage to restore it in the memory at any time when needed. So in this scenario, EclipseStore works similar to a cache implementation. So it's kind of like data storage and cache in one solution. So the object references are loaded automatically behind the scenes, and your loaded object references are automatically merged into your object graph in the memory. So there are no more classic selects. This is fully object oriented. So just have to call get methods, and the framework cares for the rest and loads and updates your object graph in memory. And so EclipseStore allows you to combine high performance Java memory data processing with transaction safety, data persistence. And using a traditional database server is not required. So you don't need a database anymore. As I mentioned, there are three main benefits. Incredible high speed because of the Java performance of the JVM, lowest data storage costs, and simple implementation. And EclipseStore is very easy to use because it's only a tiny Java open source library you can download via Maven. So the whole code is published on GitHub. It's an open source project. It's under the Eclipse public license. So you can use it for open source, but also for commercial purposes. So I like to show you performance demo. It's also available on our website, but here we can see the performance of Java data processing, or how fast is Java in memory. Here we have two applications running. It's a bookstore application. So we have around 250 gigabyte database, and one application is built with the traditional JPA stack. So here we use Hibernate, we use a PostgreSQL database, we use Spring Boot, and we use cache. So, and by the way, it's a hot cache, so data are already in memory, and the application fetches data directly from the hot cache.
Sorry, Marcus.
This is much.
Sorry to interrupt you. Your slide doesn't change, so there is something wrong with the presentation. So maybe.
Okay.
Can you just double check your presentation?
Thank you.
We still see the EclipseStore in a nutshell page. Okay. Thank you.
Better? Okay.
Yeah.
So I shared the window. This is the yellow bar. So the yellow bar represents the JPA application using Hibernate and cache. And of course, cache is way faster than fetching data from a database, because database access hard disk and is way slower. So this is almost the fastest case to reading data directly from a cache. The other application is built with EclipseStore. This is here we're still using the microstream implementation, which was the previous implementation. So the EclipseStore project is pretty new. It's we donated the whole microstream code to the Eclipse Foundation, and it's now called EclipseStore. Here in the demo, we still use the microstream implementation, and you can see the blue bar. And we see that all queries are almost 10, 100x, sometimes more than 1000x faster. And this is not magic. Here we just filter and query the object graph with pure Java, with the Java Streams API. So filtering and searching and filtering with pure Java in memory. So this is not magic. This is core Java stuff. And I guess all of you are convinced that Java is really fast. And now the problem was only how to store objects persistently on disk. And this missing piece of puzzle is delivered by EclipseStore. This is exactly what EclipseStore provides. And this enables you to now search and filter by using pure Java. And this is so much faster. So you can find more information on EclipseStore.io, and also you can find links to the code and to the documentation. EclipseStore is also part of Halidon, which is a great microservice framework. It's also open source and driven by Oracle. And EclipseStore is also part of Micronaut. So it's integrated with Micronaut. But we have also now great implementation or integrations with other microservice frameworks like Quarkus, Spring Boot. So if you use microservice framework, you can use it together with EclipseStore very easily and convenient. About the history, so the EclipseStore project is, as an Eclipse project, is very new. So we launched the final release in December, or was it in November last year? But the previous microstream project was started in 2013, and we used the framework in production almost 2 years later, and then we started to build a framework that can be used by everyone. So it's already bulletproof and stable and really fast, secure, and you can use it for your application, your mission critical applications. So it's really stable. The EclipseStore project is an Eclipse project. So the development process is further developed under the roof of the Eclipse Foundation, which is not only the Eclipse IDE. So we run more than 100 open source projects under the hood, the roof of the Eclipse Foundation. So this is a great community for us, and we work together with other vendors and companies. And the reason is it fits great with the microprofile standard and the Jakarta E standard. And our goal is that EclipseStore, or the functional principle of EclipseStore, becomes a new standard, similar to the JPA standard, and then EclipseStore will become the reference implementation. For running and for building and running distributed applications, MicroStream provides EclipseStore as a cluster implementation. But for many use cases, the EclipseStore single JVM approach is sufficient, and you can build great applications with EclipseStore. Database development with Java. So here are some facts about Java. So why is Java so fast? Because we have this just-in-time compiler, and so that Java is so fast that we really can outperform C programs because of the code of the Java code is constantly optimized by a JIT compiler behind the scenes. So this is great. With Java, we are able to search and filter with Java Streams API in microseconds. So incredible fast. The second fact is we have the perfect data structure already in Java. So we have object graphs. We can deal with single values in Java. We can deal with simple lists. You can also deal with human readable formats like JSON. That's not an issue. We can build up a complex graph structure with circular references, and also we can deal with vectors. So with AI now, vectors are super popular. It's a popular structure, and this is the structure for AI and machine learning. And we can deal with all of these data structure in Java. So from the beginning, so we have the perfect multi-model data structure in Java. That's great. Searching and filtering. I mentioned the Java Streams API. We have GraphQL. And this is incredible fast. And even if you have gigabytes, or even if you have terabyte of data in memory, and we have really a complex object graph structure with circular references, it will take only microseconds to search. So we talk microsecond response time, we talk about microsecond query time. When we talk about the performance of a database, of a classic database, then we talk about milliseconds. So milliseconds in comparison to microseconds is factor 1,000. This is why we say it's up to 1,000x faster. So great performance, unbeatable. The problem so far was Java as a programming language does not provide a function to store objects as they are persistently on disk. So this was the reason why we was used to use traditional database systems. But the problem is database systems are incompatible with programming languages like Java, because they provide database-specific data structure, like tables, or NoSQL databases provide JSON, XML, or they provide their proprietary graph approach, or vectors. So and all of these data structure are database specific, and they're incompatible with the Java object model. So with EclipseStore, we follow a completely different approach. So we follow the system prevalence approach. How does this work? So the system prevalence architectural pattern says it's super simple. So just keep your data in memory, and process your data with Java. And all changes are regularly stored on disk by creating a snapshot of your system state. So this is the functional principle. So the state is kept in memory, and you can store your system images, transaction safe on disk. And this sounds really simple, and just by using Java serialization, and many Java developers have tried this approach already. But the problem is this is also linked to many further challenges, because obviously don't want to store your whole system state. So there are further challenges. What is if your classes change? So there are so many unanswered questions in terms of this architectural pattern. With EclipseStore, we solved all of these problems, and now you have a framework that can be used very easily, and it has solved all of these problems or challenges. Here we have a traditional architecture of a database application. So let's assume we use a relational database. We have an application. So on top of this architecture, we have the application logic or microservice logic. We have an object graph in memory. We have a local cache, and we use object relational mapping framework for storing our objects in a relational database. It runs on the JVM. So this is a common architecture. With EclipseStore, we now replace object relational mapping. So we don't need object relational mapping anymore. We don't use a relational database anymore. We just use the Java object model. We use the object graph in a memory, and we let EclipseStore serialize our object graph or the changes on disk. We keep data in memory, which means we don't need a local cache anymore. So we can skip the local cache. And here we can see the architecture gets more simple. So you can skip the complexity of local cache configuration and so on. So all data are stored in a binary format, persistently in the data storage, and it can be stored in any binary data storage. EclipseStore is a Java library. It runs on Java 8. I'm not sure if this is still true. The new version should run on Java 11, but this is really the only requirement. So you can run EclipseStore on desktops. You can run it on servers, of course. You can run it in the cloud, in Kubernetes pods. Docker containers. You can even run EclipseStore with GraalVM native images. This will work. And we have also an implementation for Android. So if you're interested in building mobile apps with Android, there is an implementation, and it's the same functionality. So it's pretty much the same framework. It also runs with other JVM languages like Kotlin. What are use cases? I mean, we store objects, so there is no specific use case. So we are used to use databases for specific use cases because they have specific data structures. So they are built for specific use cases. With EclipseStore, we just store any kind of Java object, so it can be used for any use case. We can deal with vectors, we can deal with lists, collections. So there is no limitation in terms of the use case. In terms of the storage target, you can use plain files. So you can use any binary data storage. So any storage that is able to store binary files. So you can use plain files, but we recommend to use cloud object storage like AWS S3 because they are fully managed. The same with Microsoft Azure Cloud Object Storage or Oracle Cloud Object Storage. We have connectors for all of these data storages. And this might be a little bit confusing, but we also have connectors for traditional databases. So because it's possible, you can use the traditional databases for storing binary data. This is the reason why you can also use a PostgreSQL database for storing EclipseStore objects with EclipseStore. But keep in mind, there is no more relational model. So we just store binary data. So you cannot query the database with SQL. So this is not possible anymore. And we save up to 96% data storage cost or database cost in the cloud. So why? It's because of relational databases in the cloud, or also the NoSQL databases. They are also very expensive in the cloud. It's because of you need CPU power and storage. So you need computing power and storage. Here's an example for 250 gigabyte PostgreSQL running on a 4 CPU server, 16 gigabyte memory. It costs around $3,000 per year. If this database runs on only one node. With MicroStream or EclipseStore, you can now use just an object storage like S3, and 250 gigabyte S3 costs only $70 per year. So it's so much cheaper. And if you need replications, or if you want to replicate your database server, you need more replicas, which means your price will triple and skyrocket. So the more nodes, the more replicas you need, the higher the price. And with AWS S3, it's just only $70 per year, because of they care for replication, for data center replication, they care for uptime, they care for backups, fully automated. So it's so much cheaper. And we don't talk about license fees here. So if you use an enterprise database system, then yeah, of course you have to pay also the license fees, and this is also gone with EclipseStore. So incredible cheaper, save a lot of money. I showed you a performance demo already, and now what's in, what is included. So we have written a new serializer. It's now the Eclipse serializer. We use Eclipse serializer for serializing your objects persistently on disk. So the Eclipse serializer is also an Eclipse project. It's also open source and under EPL available. And we use the Eclipse serializer because of it's faster than traditional Java serialization. It's much more secure, and it's built for complexity. So the depth of your object graph is not limited. So you can really serialize any Java object. You don't have to implement serializable and so on. So many advantages with Eclipse serializer. And this is the core and the heart of the EclipseStore persistence framework. As I mentioned, for storing the objects, we provide a persistence layer for the JVM. It's a persistence layer for Android, and then we have added further concepts for legacy type mapping. So this is for the class changes. So if your classes change, then this is not an issue with EclipseStore. It's handled by the framework through runtime. It's called legacy type mapping. We have a so-called file system garbage collector, because we store objects appended to disk. And the file storage garbage collector cares for cleaning up the storage behind the scenes. Otherwise, your storage would grow more and more. We have a file system abstraction, so you can determine your storage target. Really, we have the database connectors. We have a REST interface. With this REST interface, you get access to the storage data. So you can get access to the binary data directly in your storage. And we have a graphical user interface where you can use for browsing through your storage, the data in your storage. We have native backup functions you can use if you use plain file storage strategy. If you use a cloud object store, then you can benefit from the cloud provider's backup strategy. We have also converter. So if you EclipseStore is an open system, you can import data to EclipseStore, but you can also vice versa export your data very easily. And then we have a cluster environment for distributed EclipseStore applications provided by MicroStream. So this is the whole package you get with EclipseStore. Some words about the EclipseStore cluster. If you want to build distributed applications, then with the MicroStream cluster, you get a replication infrastructure where you can very easily replicate your JVM nodes. So the system state of your JVM node is replicated through multiple JVMs very easily. The end result is a EclipseStore cluster. It's the same functionality as a distributed cache because, yeah, I mentioned already, we keep data in memory, we replicate the in-memory data. So in-memory database on an eventual consistency approach, the current version. If you want to build serverless functions, stateless applications, or you want to build .NET applications or Python, then you can also use REST to get access to an EclipseStore cluster. And this is the same for third-party applications. For all third-party applications, they can get access very easily and query EclipseStore clusters by using REST or GraphQL. All right, so how's the functional principle? How does this work? And I will jump into the functional principle, and Christian will show the code some minutes later. So as I mentioned, you can build your object model freely. So you can create a simple list and store data. You can also create a complex graph with circular references. So everything is possible. So this is the only rule. Just build an object model that fits for your use case, that fits for your application. You don't have to care for a database system and a database specific data structure. So just focus on your business logic, focus on on the best fitting data structure for your application, and EclipseStore will be able to store it. So we can use circular references, any types, collections. So everything will be stored by EclipseStore. The only thing you need through runtime is an EclipseStore instance. So with the EclipseStore instance, we create a root object, and the root object is the starting point of your in-memory database. And all objects that are reachable from this root object can be stored by EclipseStore by just calling one store method. So it creates also the storage target, and then you just have to add some objects to the root object. So, and then we just have to call a store method. So we need this root object, and then we can just add some objects to this root object, and we call a store method. And with the store method, EclipseStore creates a binary representation and stores the binary appended to the file storage. So let's create some more objects. We call a store method, and voila, we have another binary file in our storage target. So can repeat this, and we get more and more binary files in our storage target. Can store any complexity. So let's change some objects. How does this work? So if we want to change some objects, a collection, or objects in a collection, or anything else, we change this, and we call the same store, the store method, and we can see it creates another binary file in a file storage. So we never overwrite data. This is very important. There is no classic update, so we never overwrite data in the file storage. We always store the changes appended to the file storage. When we start an application, then EclipseStore loads the whole object graph into the memory. And this is now, at this point, very important to mention that not the whole object graph with all objects is loaded. Only the object IDs are loaded. So all information about the object graph structure is loaded. And then you have a kind of like indexed in-memory database. And that's it. This is very fast. And now you just have to call get methods to load objects by using lazy loading. So just call a get method, and that's it. And EclipseStore will load the object reference and will merge your objects directly in the object graph. And the JVM will provide you the object as you're used to. So lazy loading is very easy. So you can use eager loading or lazy loading. So it's your choice. If you want to load data initially, then keep your classes eager, or do nothing. Then it's automatically eager. If you want to load object references lazy, then use lazy loading. So we can load more and more objects in our memory. And then the question is, what about memory management? So you don't have to care for memory management. Everything is managed by the garbage collector, by the JVM. So the whole memory management is provided by the JVM. But you have control of your lazy references. So if needed, you can remove lazy references from memory. You can define a timeout. So you have control about your lazy references, but you also can let the JVM, the garbage collector, decide which objects are removed from memory. So this is very easy and very convenient. Searching and filtering by using Java Streams API. This is core Java stuff. And then a very important question, what is if my classes change? So for this scenario, we provide lazy type mapping. This is also very convenient. So when EclipseStore loads an object in the memory, then it compares the object with your class. And if there are differences, so if your class is changed, let's say you have changed some fields, or you have added fields or added fields, This is recognized by the framework, and then you can define a legacy type mapping and define what should happen if the classes change. And after you have stored your changed object persistently on disk, then you will have two different versions of your object in the storage. So the latest version, the updated version, and the older version, so the legacy type. So let's change more and more objects and store it on disk. Then we have many legacy objects in our storage. Now you can decide whether you keep your older versions or let the garbage collector remove the older versions from your storage. And now I let the garbage collector remove the legacy types, and so the garbage collector, the EclipseStore garbage collector, will constantly clean up your file storage behind the scenes and constantly optimize your file storage behind the scenes. And you can configure that, so you can configure the whole housekeeping process very easily. Right. The same with removed objects. If I want to remove an object references from the object graph, I just have to call the store method again to store the new object reference on disk, and the garbage collector of the JVM will remove the objects from memory, and as soon as you store the object again, it's also removed from the storage. That's the functional principle. As I mentioned, memory management is provided by the JVM. You have fully control of your lazy references, and the JVM matters. So keep in mind, you have with EclipseStore an in-memory, or the end result is an in-memory database. So the faster your JVM is, the faster your application in memory is, the faster your database is, of course. There are differences between the JVMs, and there are also differences between the JDK versions. So it's very interesting that the latest Java versions are the fastest. So here we have differences between, so up to 10–15%. So and also you can or should check out different JVMs like OpenJ9 or Azul JVM. So they provide improved data management or memory management. You can save memory, and they are faster. It depends on the use case, so you should check this out. And so you can speed up your EclipseStore application, your database application, sometimes between 5 to 15% or even more, just by optimizing the JVM. So it's built for simplicity. So many users are interested in the performance of EclipseStore. That's great. Others are interested in saving cloud costs, database costs in the cloud. But developers are mostly interested in simplicity, right? So implementing and using EclipseStore is really so much more convenient in comparison to a database. It's because of you don't have to learn database specific stuff. You don't have to learn another query language. You don't have to deal with database specific data structure. You don't have to build your object model around your database model. It's just core Java stuff. There are no requirements to your classes. You can just use POJOs. There are no requirements to your object model. Of course, you can also build nonsense with EclipseStore. So you should be careful how you design your object model, but this is core Java stuff. So do it like Java developer, then that's it. You don't have to care for any database stuff, and you have to think different. So forget everything you have ever heard of a database server. This is a completely different approach. Yeah, just Java concepts, and this is what we had in mind when we developed EclipseStore, or started with EclipseStore. Just to focus on Java, just use a perfect model, the object model of Java. High performance, of course, it's always a topic. So most Java projects have problems with performance, or database applications have challenges with performance. So with EclipseStore, performance should not be an issue anymore because of the power and the performance of the JVM. It's real time, so real time processing is possible, and you can reach really extremely workloads and throughputs with EclipseStore. Wrapping up, cost savings, of course, I mentioned you can use object store in a cloud, and it's more than 90% cheaper than a comparable database, and you don't have to pay license fees. But there are also some rules, and of course, there are also challenges with MicroStream or EclipseStore. And let's talk about the rules and the challenges. The function on the left side, you can see again the functional principle of a database server. So here your database is located at your database server, and you search and filter on the database server, and this is very important. And there your persisted data are of course stored at the database server side. With EclipseStore on the right, we can see now your database is located in the same JVM process as your application is, and you search and filter, so your queries are executed in your application, within your application, embedded. So it's very important. This is really a paradigm shift in database programming. There is no more database you have to query, or you can query. That's gone. And we have just the storage data. You have the binary data in the storage, and you cannot, this is very important, you cannot query the storage data in your storage. This is impossible. These are the binary data. They have to be loaded into the memory, and then you can query and filter in memory with Java streams. And you might think, oh, okay, this might be a problem because of I have to load the data in the memory. Is this really more efficient than a database server? So we provide specific collections you can use. This is not mandatory, but you can use it. Then we also provide, and this is very new, a new index API, and this is so much faster. But yeah, check this out. But this is the functional principle, and you have to keep in mind, you have to think different. You have to think object-oriented, and yeah, please forget everything you have ever heard about a database server. And it's not just another NoSQL approach. It is NoSQL because of it's not relational, but it's not another SQL database because NoSQL databases are also database servers mostly. And this is not a database server anymore. It's in memory. So traditional in-memory databases, they run in memory, and mostly you have to load the whole database in the memory. With EclipseStore, you can do that. It's recommended if this is possible. This is the fastest application you can build. You have all data in memory, but this is not required. And so you can also have just 4 GB memory and you have a huge storage, a huge database, and just 4 GB memory, and you can also run an EclipseStore application with a Lambda, with a AWS Lambda, with only 500 megabyte of memory. This is basically possible. But of course, the more memory you have, the faster your application will be. So memory is recommended, but not mandatory. And keep in mind, we don't need a cache layer anymore. We save a lot of database replicas, so you can now spend a little bit more memory for your application instances, if this is possible. So the biggest challenges are, it's built for Java developers, so there is no more SQL interface, so it's not suited for DBAs. It's not built for DBAs. It's not for .NET developers or Python developers. It's a pure Java approach. It's a paradigm shift in database programming, so I have to think different. There's no SQL support I mentioned already. And it's a storage engine. It is a storage engine. It's not a database management system. Why? It's because of we have recommended that with Java we mostly, or Java developers mostly, use the whole functionality of a database system. So with the JBA standard, for instance, we don't care for stored procedures or stored functions. So 50% of a database server is not used by Java developers, mostly in practice. So databases provide security, databases provide user management, locking and logging, but mostly we implement this in Java. And
I'm not sure if it's only for me, but Marcus, your screen is frozen and we can't hear you.
So let's give it a minute. Maybe there are some issues with his internet connection. Okay, so let me jump in. So maybe he comes back later. So he left the training. Maybe that gives me a bit to answer some of your questions. There are a lot of questions regarding clustering, and so let me just activate the video. Okay. Yeah, there are some questions regarding clustering and so on. And there is this is always a big question, how to horizontal scaling stuff. And yeah, I have to say this is a really complicated topic. So this is why we provide a horizontal replication within our microstream cluster. And even we released that cluster in a beta version for now, or at the moment, we are still working on accelerate the replication in the background. So that makes it so hard to answer your questions about some latencies and stuff like that. It's still, I would not say work in progress, but there is a way we replicate the data, and that provides a high availability. But yeah, we are still working on acceleration and improvement of that replication. So that's basically how it is. So that means for the moment we provide our services within our cloud infrastructure, and this is also available, or this will be available for you as an on-premise solution. So that the way we replicate the data, to be honest, it's just some Helm charts and how to install them on Kubernetes and so on. This is how it basically works, and this charts and all the setup will be provided to you together with our replication framework. And the replication framework is part of our enterprise solution. That means it's also development is ongoing on that, but there is basically a way to horizontally scaling your data to achieve a high availability. But it's quite hard for me to talk about latencies and so on, because it's still ongoing. We're still working on that. I hope that answers your questions a little bit. On top of that, I have to say we are now at this is a fundamental training, and the things we talk about is it's quite extended topic, I would say. So let's start at the basics. Maybe there are some of you that have still questions, and that these questions will be answered within the next few minutes. Okay, is that okay for you for now? Maybe we come back to some topics later on, and then we can talk again about that. But let's start with the basics, I would say. Okay, let me share my screen. I think that's also important. Okay, you can see my screen, right? So you should see my Eclipse IDE, Eclipse IDE, and you should see some code here.
Yes, we see it.
Okay, great. Yeah, as I said, let's start on the very basic steps on how to use EclipseStore. And for now, it's okay to lean back and just see what's going on there. So I started with a very basic project. It consists of it's a Maven project for sure, and there are some packages here, and there is one main class. And we need that menu, and let's do some coding stuff. But as I said, lean back and just look what happens. So when you have a look to our documentation, especially to the getting started part, you will see code looking like this. That means there is something with an embedded storage manager, and I think that's except let me just share the dependency with you. This is the main dependency of EclipseStore. As Marcus said, it's just a framework, so you can add it to any Java, Kotlin, or some Android application to use it within that application. And at the moment we are on version 1.8. When you remember the MicroStream version, I think the latest version of MicroStream is 8.1, but as I said, they are the same, so you can directly switch from MicroStream to EclipseStore without any changes. Or to be honest, you have to change some imports, but that's it. And the storage works the same. There are no differences between MicroStream 8.1 to EclipseStore 1.2. One special thing is we improved. There is one issue. Let me just say, I think 1 week or 2 weeks ago, there were a big issue with Java 21 with the newest version, and that's the reason why we changed to version 1.2, and this is the latest one. Okay, so we need this dependency, and then this enables you to create an embedded storage manager. And that storage manager represents the database itself. That means whenever we want to store something or to do something, we need to reference to that storage manager. There is another thing we need all the time. We need one root object. This is the top entry object to the object graph. It's also possible to have multiple routes, but to be honest, I never used multiple routes because in this specific part, I just added one string, and this string is hello world. Hello world, and that's okay for now. But some of you are a little bit confused about storing just one string in that route. Does this make sense? I thought that it is a database and we have a tree. As I said, it's just a very basic example. And in this specific case, we store one string. It could also be one object based on your structure. But yeah, we come to that later. So that means at the end, we add a string like this, and then we call store root. And that's it. That means store the root object because the root has changed in this specific case. And this is one really special thing. You always have to store the object which has changed. So, and that's important. Okay, and at the end we do a system print line, but that is not really important. But let's start that example and see what happened. Okay, okay, let's start it. And let's see what happened. Okay, there is one issue. Let me just check, do a Maven update. There is something wrong. Okay, you see now you see the hello world here, and that's it. When we have a look to the project structure here, we store this hello world string directly to the file system or to the hard disk, and this is why we have why there is the storage directory here on the left, and each storage consists of multiple channel directories. Here we in that case we have the channel 0. We could have multiple channels on the storage. This is a more advanced topic, especially for the advanced 1 or advanced 2 training. But for now, it's important to know it's possible to write down data multi-threaded, and then it's each channel consists of one thread writing down the data to the hard disk. And in that case, we only have one thread, and this directory contains the data. There is one channel data and there is one transaction file. And there is another important file, which is called the persistence type dictionary. And just for a short explanation of that type dictionary is you have to, it is your storage consists of just binary files. So that means when we store the data, it's one big binary object, I would say. And each object type has its own type ID, I would say. And within your storage, each line, I would say, each line of a binary string consists of a type ID and an object ID. And this is how we managed the relation between the objects. So that means, for sure, you handle a tree or a graph within Java, but in the end, on the hard disk, it's just a binary blob object, I would say. And we MicroStream or EclipseStore doing the thing automatically in the background to load the objects and so on. That's handled in the background. Okay, let's move on. This is just a really basic example. Let's create a more advanced one, or one example that makes more sense to me. So we create one my company object, and we use that company object as a root object. So it doesn't have to be an object based on your business objects. It could also be just any object which is called root, for example. It doesn't matter. Important is there is one on top object of the graph. In that specific case, it makes sense. I created an object which is called my company. And that company object is handovered to my EclipseStore manager or my embedded storage manager. As you see here, this is the root object. And in the second part of that start method, I hand over the path to store the data. And there was one question from your side: does it make sense to store data to the file system, or does it make more sense to store it to an AWS S3 bucket, for example, or even to a normal relational database? Everything is possible. And yes, it makes sense because some of our customers uses EclipseStore in a way that they normally use the file storage as the primary storage, I would say. But there are some backup mechanisms in the background. So that means we are able to write a mirror, for example, to a different storage. And then it makes sense to have several connectors to different storage targets. That means we are able to write the mirror directly to AWS S3, for example, or we write the mirror for any backup purposes to let's say PostgreSQL database. So, and that's why we provide those connectors to the storage. But we always recommend to use the file storage itself or a persistent volume or stuff like that as a primary storage, and then write down the mirror to an external storage or blob storage. And there is also a possibility to create a full backup. And also this full backup can be written to a different place. Yeah, give me just a second. I will come to that later. Okay, so let's move on. So we need 2 additional objects, and therefore I created some customer objects here, customer and customer 2. And my company has its own structure in it. Let's jump into it. You see that there is one list of customers within that company object, and you see now it's not only a string. Now this company object can have multiple data structures in it, lists and hash maps and so on. It's totally up to you which data structure you choose. There is one limitation I would recommend is please don't use any third-party objects within EclipseStore, because in some rare cases a third-party object can change from version to version, and this could lead to a big issue within EclipseStore. So just use the normal JDK data types and the normal Java data types. That's totally okay, or use your own Java objects, but don't use any third-party objects. That could lead to an issue at the end. Okay, so that means I created 2 customers here, and I add these customers to my company get customers collection. And the only thing I have to do now is I have to store the thing which has changed, or in other words, the reference holder has to be stored. And this is what happened here. So that means we have our collection within the company. We added the customer, and with that we changed the collection because we added some customers, and that means that we have to store the collection itself. And this is the reason why I call the store method here. Some of you might ask, okay, why not to use the store root instead of store? That could also be possible. The point is, with EclipseStore, all the things you store and update and stuff like that will be attached to the end of the storage itself. This is nothing you have to deal with, but you have to know it, because when we call store root, means that the whole storage will be attached to the end of the storage will be attached to the binary file. That's okay in such a small project like this. Then this is not a big issue. But in bigger bigger databases, I would say more than gigabytes of data, it makes sense to please don't call store root. This is not the best way to handle that. Okay, so we call the store method, and after that we shut down the storage. That's what we need to do here. So let me just double check if everything is all right. So we write down the data to a folder named data. That's okay. Yeah, let's start. Let's see what happens. So just a second. Okay, storage channel is stopped. Everything is all right. Let me just refresh the basic example project. And here we are. You see the data folder is created. So it's the same structure as the storage one. This is the storage folder from the example before, and this is the new one, the data. And now let's see if the data is in it. So we would not need this anymore. Just use the sysout, and that's it, right? So we don't need, yeah, we need that. Okay, that is okay. Then we initialize the embedded storage manager. That's okay. And then we sys out the customers, or we stream through the customers. And after that, we shut down the storage. Okay, let's see what happens. So we should see here we are. You see that? And here we have our two objects that are stored within the storage. And that means, okay, now these two customers are part of our storage on the hard disk, on the file system. And this is how it basically works. That's it for most of the most complexity part of EclipseStore is to understand what to store. But yeah, there are some further things we have to talk about, but this is quite easy. Let me just double check your questions. So so there is one question. What happens if my own domain changes after being saved or serialized? A good question. So let's open a book entity, for example. So there are many different possibilities that can happen on a book. We could add something, or we can move the ISBN from here to, we could move it down there, and so on. Many different things could happen. And in the background, EclipseStore, there is a kind of like a versioning is working in the background. So that means there is an heuristic running in the background, and when you start up an application, EclipseStore is able to see, okay, there are some changes on several objects, and EclipseStore will manage most of them automatically. That means, for example, especially when we change the name or stuff like that, so EclipseStore will handle that automatically. And it works like an versioning. That means whenever an object in that specific case, a book object is opened or is read, it will automatically be transferred to the newer version. So you could see that just a second. I could show you this. This is also a part of the advanced training, but I think it's important to know that before. And we have enough time to talk about that. Okay, so let me just open the persistence type dictionary. Then I can show you this. Okay, here we are. So this is the part of the type dictionary. So this is our customer object, right? So this is what we have stored. This is the structure of the customer, and that customer has the type ID, this one, 75 something around it. So when we now change something within the customer, so let's move back to the customer object. And now let's change the name from mail to mail2, or let's do a different thing. Let's just change the structure a little bit. So move mail down there. So, and let's start the application again. So data main. Okay. Okay, so you see application is still running. We see the sysouts. And now let's check if something changed. Yes, and that's how it basically works. So you see there is a second customer with a different type ID. Now with a new type ID 77, that means you see the different structure, and this is how it basically works. There is a kind of like, as I said, a versioning behind the scenes, and it changes the objects whenever it is touched. And that means that when there are some objects which stays untouched for decades, I would say, so then it's okay. They stay on the lowest version when they was created, I would say. And this is how it works. Okay, so many questions. That is incredible. Oh, Marcus is back again. Okay, great. Lost connections. Okay, so let me just, what happened if changed? Would your own customer we consider third-party objects that are not standard Java? The point is, as you can see here, when we talk about objects, so regarding the third-party object, right? So that was the question. You see that we always use the full class path name to identify some objects. You see that here. Yeah, this is the full class path, and sometimes, especially on third-party libraries, for example, what happened if the class path changes of an object? And this could lead to an issue because EclipseStore is no longer able to find that object within the class path, and that is why sometimes it could be an issue to have third-party objects. And there are some really special data types within the JDK and so on, which cannot be handled within EclipseStore. But you could see that within our documentation there are a list of unsupported data types, and maybe some of them are within those third-party objects. I hope that explains that thing a little bit. Another question is how necessary is shutdown? Shutdown, I would say a shutdown is always important, especially when we talk about Kubernetes and Docker containers and stuff like that. It's always important to take care about a gracefully shutdown of your applications. So whenever you have the possibility to shut down things gracefully, you should do that. Normally, it's not that important. EclipseStore will take care about those things internally, but especially with containers, and let's imagine you write bigger objects to your storage, and during that write or during the access write down data to your hard disk, you kill the container or stuff like that. This could lead to an issue or to lost data at the end. So whenever you can, you should use shutdown, or this is also a topic on the advanced 2 training. There is a special talk about exception handling and gracefully shut down stuff within EclipseStore. Yeah, another question: if you store my company instead of the customer's collection, is the collection updated? Is storing the collection more performant? The point is, as I said, the basic functionality of storing things is to store the reference holder. That means you have to store the reference holder because storing my company would lead to store nothing, because within the object my company nothing changed, right? So so let's say we initialize a new list of customers. So then it makes sense to store my company, because my company is the reference holder of the collection. But in my specific case here within the main object, we added things to the collection itself. So that means the collection itself is the reference holder of that customers, and therefore it's necessary to store the reference holder. There are some store methods that could store things, how to say, traversely. Is that the right word? I guess I'm not sure about that, but there is a possibility to say, okay, this is the first object and store everything below that object. That's possible, but this is, I would say that's possible, but not the recommended way basically to do that. Okay, the file PDD have you created self, or is that? Well, yeah, this is created automatically. So so let's do that. So let's delete data and let's delete storage. Now you see both files are deleted. So we don't need this no longer. My company. Whenever we start that again, this folder will be recreated on if it's if it's not there. So if there is no folder called with the name data, it is created. So this is made by EclipseStore in the background. You don't have to take care about file handling and stuff like that in the end. So let me just start this so to see that again. And now you see this data folder is created again, and it contains a persistent type dictionary. This file is a quite important file, because without that file, I would say it's impossible to read the data anymore. But it's like on all the other systems, on the other database systems, when you delete some files in the background of the database itself, data will be lost. You will not be able to access the data anymore. So that means you should not access or doing things when you not know what to do, or what you don't know how to handle this. Okay, some more questions from your side. Markus, I'm done with the first topic. Do you want to add something, because your connection lost? So otherwise, I would do the break now. I think it's time enough to do the break. What you can do during the break. So the next example I want to work on is the step-by-step configuration project, and you could use any Java IDE of your choice. You should be able to start a Micronaut application. This example is based on a Micronaut application. Let me just share you the link to that repository. Just a second. Here we are. So this is the link to the example. Just check it out. You can start on the, let me just check the branch. Just start on the beginning branch. There is one branch which is called beginning. Let's start on this. But let's do this after the break. So, but the break gives you time to set up your IDE or stuff like that, or to import the project itself. And then you will be able to code along with me. And this project will guide you with several branches to the whole project. But I will do this together with you. And on each step, I will explain some special things you have to know. Okay. There is no IDE plugin you especially need. The only thing you have to do is you have to enable your, let me just check. You have to enable your annotation processing. So it's part of the of the Maven settings, especially on Eclipse, you see when you go to the preferences on the Maven preferences, you see that annotation processing thing here, and you have to enable, or you have to set it to experimental or automatically. I think it's the same on IntelliJ, but to be honest, don't ask me where to find those settings. Maybe some of you can help a little bit on the chat to enable this annotation processing. How to break up the section in your Eclipse project management view. I'm not sure if I get it right. So how to break up the sections? I think this is a special IDE that there is a plugin which is called Rapid Clips, and it looks a little bit different. But you could use any Java IDE of your choice, and for sure it looks different than mine. So, but I think it's okay. So step by step. But let's go to the break. Okay, there is one question. What will happen if an already persisted domain object completely deleted or renames a field? Okay, if it is deleted, so I think to answer that, we have to clarify how to delete data. I think that would help. And that brings me to the CRUD operations sections of the training. So I will come to that later. And renames a field, I hope I answered this already. It's kind of like, as I said, kind of like a versioning. So that means you change the name of the field. EclipseStore detects that in the background, and whenever you touch an object type of this, it will be transferred to the new object. And that means at the end, you have 50% of your objects are transferred to the newer version, and 50% stays the old version if they stay untouched, I would say. And this is how it basically works. But more in detail to that type versioning and so on in the advanced one training, I guess in 2 weeks or something like that. Okay, but the deletion stuff, I could answer that a little bit later. Okay, so I shared you the link to the step-by-step configuration project. There are multiple branches, beginning, project setup done, and so on. That means it's totally up to you to jump from one branch to another. Or you code with me along in one branch. It's, as I said, it's up to you. I'm gonna start on the beginning branch, and I will switch to the next branch soon, because the only thing which has to be done in the beginning branch is to add the dependency. And let me just double check the dependency here. And I just want to check if there are all dependencies that we need in place. No, it isn't. So, okay, let's add those dependencies. And there are mostly 2 dependencies, in my opinion, that is necessary. So just a second. So here we are. Okay. Okay, these are the 2 important dependencies we need. So as I already explained, this is the main dependency, storage embedded, with the version 1 or 1.2. So this is the latest one. And there is a second one, and this is a special one whenever you want to configure the storage manager, or to configure the embedded storage manager. And there are a lot of different stuff you are able to adjust and doing configuration on that. But you will basically need these 2 dependencies, and that's all. One for oh, sorry, one for the embedded storage and one for the configuration stuff. Yes, I forgot Lombok. But yes, I'm not a big fan of Lombok, to be honest. Maybe it's a great framework, but when you use records, often you don't need Lombok anymore. And yeah, as I said, I'm not a big fan of Lombok, but okay. So as I said, these two dependencies are important. And this is all we have to do within that branch. So let's move on. Let's directly jump to the next one. Let me just close this, and I also jump to the project setup done. Okay, let's see what happened in the next branch. So, okay. So the first thing we need is let me just check if I'm right. So okay, here we are. So, okay, the first thing we need is a DB class. So most of the time I create a class like this to initialize the storage itself. And yeah, let's do this. So let's create a new class within our folder. Let's say new class. Let's call it DB. The name is totally up to you. We have to create a class like this. And because we need a static storage manager, and yes, there are thousands different ways to initialize a storage manager to handle it as a singleton storage manager or stuff like that. There are always also the question: is it possible to have multiple storage managers in one project? Yes, it is. You could have multiple those things. And but yeah, let's create a DB class, and especially for the training, let's add the first line we need. It's the storage manager itself. So we need one embedded storage manager, and in my specific case, I use this static to ensure that there is only one storage manager which is available. And we need a second thing. We need our root object. As I already explained, we need one entrance object, I would say. And in that specific case, I called it data root. And you see, there is no object of this type available. And that brings me to the next step. Just create a class named data root in the same structure. So that means at the end we have the DB class and we have the data root, and we initialize the data root directly here. And in this example, I used a static block at the end to initialize the elements. And this is another way to initialize. We already seen the fast way, the fast initialization, I would say, and this is one of my favorites. So let's say, okay, storage manager. Let's initialize the embedded storage manager equals, and then we use embedded storage configuration. And this configuration has a builder pattern, and that gives me the possibility to create, to say, okay, let's say set storage directory. And there are two methods available. One is set storage directory somewhere on your volume or somewhere on your hard disk. And there is another one in user home. It's up to you which one to use. In my case, I say, okay, set storage directory. Let's call it data, because, or you could also say, let's call it storage or whatever. It's up to you. And you see there are many different, many more possibilities to set a backup directory, for example, a channel count, a maximums file size, and so on. Many different possibilities. Housekeeping could be interesting later on, but we talk about that in further trainings, and some of them are today also today. But that's okay for us for now. Based on that configuration we create, based on that configuration object, we create an embedded storage foundation. And it's always these 3 steps are needed to create or to create an embedded storage manager. Create a configuration. Based on that configuration, create a foundation. And based on that foundation, we are able to create the embedded storage manager. And this storage manager can get, or you can hand over the root object. And last but not least, we call the start method, and that's it. And this is a great way to initialize the storage manager. In Spring Boot, there is one question: how to initialize in Spring Boot. This is really quite easy. You just have to do some settings in your Spring Boot YAML files, and this enables Spring Boot to initialize the storage manager in the background, and then you can use some injection stuff to access the storage manager. Just check out the example we provide on our GitHub, and also in the documentation there is one big example of Spring Boot 3. Okay, this is it. Some of you always ask, okay, why to have those 3 steps? What is the reason for having a foundation like that? The reason is you can do different things on different layers of the storage. There are some adjustments possible on the configuration, but there are also some adjustments on the foundation which cannot be done on the configuration side. So especially when you have really special configurations, and some of them has to be done on the foundation. Especially when you create further examples or more complex examples of that. Okay, so but these 3 steps are important. We create a configuration, then out of that, based on the configuration, a foundation, and based on the foundation, we create a storage manager. And at the end, we say start, and that's it. So whenever we access the DB class, our storage is initialized or will be initialized, and that's it. We hand over the root. And that's all we have to do to initialize a storage. Okay, so let's have a look to the data root. It's empty, or it should be empty. That's it. Application itself, it's like it is. So nothing special or nothing more to do. Let's jump to the next branch, right? So this is next step. So next step is to create some entities. So let's create one package, and I named this package domain for my domain object. And let's create 2 different domain objects. One is an author object and one is a book object. So let's say new class, let's call it book. And another one, let's call it author. So are you still there, or am I too fast, or is it okay for you? Should I stop a little bit, or? Okay, great. So if any questions, or if you have to stop, or if I should I explain something, feel free to interrupt me. No problem. We have enough time to deal with that. Okay, 2 objects, author and book, and let's add some fields. So let's say, okay, let's call it private. Each author needs a mail, for example. Let's call it mail. Private. Oh, come on, what's wrong? Private string first name and private string last name, right? So this is what we need. That's it. Let's create get and set methods. And yeah, we not necessarily need a constructor, but let's create one. Here we are. So same on the book object. Let me create private string, let's say an ISBN. This is also an important mostly an important question. What about identifiers and so on? But I will come to that later. Private string name and private author. That's it. Let's create get and set methods, and also let's create one constructor using the fields, and here we are. So I think there are the first, you can see the first slightly differences between a relational model and a data model, which is a part of EclipseStore. We don't have those table lists anymore. So we don't have a table list of authors, for example, or a list of books in that case. But yeah, we come to that later. So in that specific case, our author is part of a book, and that's it. So for now, we don't need a list of authors, but we have to store books, right? So somewhere we have to store our books, and this is what we have to do within our data root. So that means let's create a list of books. So let's say private final list, list of the type book. Let's call it books equals new array list. It's to be import. Yeah. Okay. So book. And let's create one get set method. Okay, that's it. This is our data structure. Nothing special. But the interesting part here is we get asked all the time, do we need some special annotations and stuff like this? No, we don't. Just use your entities as there are, use your domain objects as there are. There is no annotations needed. Everything is handled by EclipseStore in the background. One question from Javid, right? If this is a web server with multiple threads, how do we avoid concurrency issues? A really good question. There is a big topic on the advanced 2 training, especially for concurrency issues. So I would say there are 3 different layers of concurrency. The first one is the technical layer, right? So accessing or deleting stuff from a collection during others are streaming through the collection, right? So this is the technical aspect of concurrency, and of course you're right, you have to handle that. So all the other concurrency stuff, I mostly call it business concurrency. So what happened if user 1 and user 2 and they store at the same time, and then it's always the last store is the leader, I would say. But this is business aspects. So, but on the technical things, you can do all the Java native stuff to handle those. And I would recommend to use immutable objects, for example. You could use synchronized if you want. You could use reentrant read-write logs, for example. And there are so many possibilities. I think the point is you have to take care about concurrency anyway. So, and this, I think this is one point on the con side of EclipseStore, that you have to handle, you have to deal with concurrency, but on the other side, you will get back an insane amount of performance out of that, and that's okay. But the answer is use whatever Java provides you to handle concurrency. In some parts, also a concurrent hash map could handle this. So many things you could do. But from my side, the best thing I would recommend is to avoid concurrencies. And this is also possible, especially with EclipseStore, but I will come to that later a little bit. Does that answer your question in a way? More to that and more examples to that on the advanced 2 training. Okay, so we created our data structure. DB class is in place. Something more we have to deal with in that branch? No. Let's move on to the next one. Controller. That now it's going to be interesting. So as I said, this is a normal, Micronaut project, and there is a reason for that. Why I choose Micronaut, especially within the trainings. The point is, whenever we want to add a book, for example, or if we want to delete a book in our projects, I always mostly need a UI, for example. And Micronaut gives me the possibility to create some controller methods, and then we could access via REST. And that makes things easier with Micronaut. And that's the reason why I choose it. And to create one REST interface, let's create a new folder here. And let's call it controller. And now let's create a controller class and call it book controller, for example. And I know there are some points of that code we type which is not the right way to do it. I'm totally agree with you, but I tried to keep it as simple as possible, especially for the aspects of EclipseStore. We just want to focus on EclipseStore. There are some, this is not a training for Micronaut itself, and there are a lot of things that could be done or could be better, a better implementation. Yeah, don't judge me that hard. So for some things, okay, let's try to create one some REST endpoints. So we need our controller annotation here. Let's add controller and let's call it /books. So whenever we call the application at the end within the browser, so we will call books, and then we need one method. So let's say public void, and we want to return an HTTP response, which returns a string, and let's call it create books. And let's make a GET request for that. And this is also a thing why I choose a GET, because it's a create. Normally it should be a put or a post. That's okay. I choose a GET because it's much easier to call it within the browser. So and therefore I use a GET. Okay, there are a lot of things to type for, and to keep it, to shorten it a little bit, let me just copy paste that stuff because there are a lot of things to type, and it's just the initialization of some objects which are needed. So let me copy paste that from. So now you see, so I created 2 authors, and I also created 4 books, and I added the authors directly at the end of the constructor here. That's it. And now we have to store those books, right? So let's move on to the DB class. Let's say db.root. So that's it. This is how things works within EclipseStore, but we talk about this on the CRUD again. So let's say root get books. We have to add things. So let's say add all. You see normal Java method, and let's add those books. And I choose the collection utils for that. Collection utils dot set of, and then I could add a book and dot book 2, book 3, book 4, right? So here we are. So normally I would create some, I normally called it data access objects and create an add method within, and normally I would not add the DB call directly to the controllers, but that are only details. So db.root get books at all, and so we already knew what to store. So I always this is important, because in my opinion that's the biggest mistake is made by working with EclipseStore, storing the wrong reference, and that's always a big issue. And I always said you have to store the thing you have changed. And in that specific case, we changed the collection itself because we added something. Then we have to store the collection. So let's go to the storage manager. Let's call the store method and then hand over the book collection. Here we are. We have to return the HTTP response. Let me just copy paste this. Nothing special. Books successfully created. Which key have you pressed to add the code IO micronaut? You mean the imports here, or this one, right? So there are several possibilities. Control, let me just double check. Control Shift organize imports, right? So Control Shift O. Moment. Sometimes there are different possibilities. You could do it like this. Hop mouse over and then say import DB. That's one possibility. Or you use Control Shift O to organize imports up there. That's quite funny. Sometimes when you have to explain shortcuts, you don't know how to explain the shortcuts because you don't think about when you press it, right? So but to explain it's quite hard. Okay, so this is the create books method, and then we need a second one. That's the easiest one. How to get those created books back. So let's use another get method here, and in that case we return a list of books, and that's it. So no worries, there are some more complex examples in that training. That's just an easy one, just to give you an idea how EclipseStore basically works. And this is also a great example for those of you who are asking, okay, how to access one storage from multiple instances. This is also a big answer, which is asked all the time, because you are used to do it like this, right? So you have multiple applications around one big database, and you access from different applications to one database. This is how it is made since multiple years. And I think that's not the best way to do, right? Because that could lead to issues to access with different applications to one data storage. This is not best practice to do it. And this is the reason, that's also the reason why we said it makes sense to have one EclipseStore instance per JVM, or one JVM per instance, or per persistent storage, because you could spread the data via REST, and this is how it is. You can do this in that way with Micronaut, for example, to provide the data to all the different consumers, I would say. And there is another aspect. I think that's also important when we think about storages. We all knew all that microservices stuff, right? So, and I'm pretty sure microservices are not the best choice for everyone. So, but microservices gives you an idea how to split up your application parts. And in that case, this is quite curious always for me, because people come to me and ask, is it possible to store terabytes of data to EclipseStore? And I always ask, do you really need multiple terabytes of data all the time available at high speed? And most of them answer, okay, no, not really. There are a lot of data which is just archived data, but it's also in the database, and stuff like that. You understand? The point is, most of the time, people searching for high-speed solutions, but at the end they put everything to one big data storage. And especially EclipseStore gives you the possibility to split up your data. For example, you could have data provider for customers, data provider for companies. Why to have everything in one storage? Split it up, or use different storage solutions for different type of data. That's the idea behind, I would not say behind microservices, but it's behind a good application data or application architecture or data structure. So choose the right storage technology for the right type of data, I would say. And this is also a big aspect of EclipseStore. It is made for in-memory high-speed data processing, right? And maybe that solves a lot of your problems. This solves not everything, but most of your problems. I think that's an important point to understand the idea behind EclipseStore. Both controller methods have the same path. Do they? Ah, you're right. Okay, thank you. I had changed the branch on startup anyway, but thank you to mention that. Yeah, of course, you are right. We need create path on the first one. Yeah, I missed that. Thank you. Okay, so that's it. So we have a DB class data root, we have controller classes, everything is in place, we have domain objects. Okay, so are we good to go? Yeah, we are. So as I said, sometimes some smaller things are going wrong during live coding. So, and that leads me to switching the branch. The code should be the same. Team switch to books done. Okay, as I said, the code is the same. Let's start it. So the only thing you have to do is, if you want to start it, just open your application class here. And let's say run as Java application. And you should see, it should look like this. Startup completed in something. And you see here is the URL. So you just go to your browser and type localhost 8080, and then you should add books. Just a second. Yeah, you see that? So I called localhost 8080/books, and you see this in your console. So that means MicroStream or EclipseStore is startup. You see the embedded storage foundation is created, storage manager is up and running, stuff like that. There is no data so far in it. So that's the reason why it's empty here. And yeah, this is how it works. So the point is within the get controller, the books controller, we try to access to the DB class, right? So within this method here, we try to access the DB class. And that is the reason why within the static block, the DB is initialized. And there is also a possibility to initialize it on startup. That's totally up to you. And let's move on to the next method. Let's call book/create. You should get a message like this: book successfully created. And when we now call books again, you should see those books at the end. So let me just check is / in the response. What do you mean with //? Not sure if I get it right. First two lines. This one here. So the initial. So let me just. I'm not sure if I get it right. So you just have to call the local host 8080/books. Yes, it is. It is JSON. It is because but the result is empty. That's the point, I think. Okay, I see. So let me just refresh the project. So you see there is the data folder here because the database is created. So let's delete the data folder here. Let me just restart the project. And let's call localhost 8080/books. So you see the result is empty. It's an empty list of elements. So that's the reason why it is like it looks like this. But when we call the create/create method, then we get the book successfully created. And when we now call the same endpoint again, now we see the JSON at the end, the JSON structure. I'm not really sure what the reason is for these two lines up here. I think it's the browser itself who creates these two lines. It's a Chrome extension, I guess. Yeah. You are right. Yeah. So you could use a postman also to call these methods. So that's totally up to you. Yeah. You are right. So this is the raw how it looks, the raw type. In the section main results, which function have these files, YAML and XML files? You mean these files here, or this here, right? So application YAML, resource files, and logback XML. These are files which are automatically created by Micronaut. They are for the project itself. When you create a new Micronaut application, you will get those files automatically. You don't have to create. The application YAML file is mostly made for yeah, for all that stuff you need to have within your application, especially when you use the Micronaut implementation of EclipseStore, you add all the configuration stuff of your EclipseStore storage within the YAML file. It's for the special integration. Okay, that was our hands-on demo. And if there are no further questions, I would move on directly to the CRUD functionality. Just have a short look to how to handle those create and read and update methods. Let me share the project itself. So show streams. Oh, I have to double check the topics first. So okay, yeah, let's have a look to. There is another project, a little bit more extended one. One moment, I have to clean up my stuff here a little bit. So CRUD operations, here we are. Let me share the link with you. That's the link to the next example. And this is an example we just go through and talk a little bit about the different things. So let me close this. I already have that CRUD project already in place. And let's directly move to the CRUD implementation done branch. Yeah, okay, that's interesting. Okay. Okay, let me explain this. Before we get into details, let me explain the project a little bit in detail. So it's always the same. We have our dependencies within the POM XML. It might be, yeah, it's version 1. You can see here we use the same 2 dependencies, configuration and the normal storage embedded. That's it. Nothing special here so far. There are some more classes down here, but the normal things we already talked about. So we have a DB class in place, we have a data root object in place, we have books and authors in place. I would say it's mostly the same than the other project. We have a book controller, and that's it. The special thing is the type of initialization of the storage itself. It's a little bit different. And in that specific case, I used, let me just double check. Yeah, I used the XML version of initialization of MicroStream. It's very similar to using EclipseStore within a YAML file. It's also possible to have that within an XML file. It depends on you to handle this. So you see there is one property which is a new one, which is called the channel count property. Yeah, let's do it like this. As I already explained, each channel has its own writer thread to write down the values to the hard disk multi-threaded, and that's why we choose channel count 4. And storage vector is data as always. That's okay. And this is normal Micronaut code to use an XML file. It's nothing special. So, but it's totally the same than before. We have a mockup utils class, And you see there are two JSON files, one with authors, one with books. And each file consists of, sorry, 1,000, I guess. Or there are 1,000 books here. Let me just check. Yeah, around 1,000 books. And I created this to have some data in place to play around with. I think the important part is the controller class. And let's get into it. So hopefully my voice will hold this evening. So, okay, so let's talk about the create book controller. And as you can see here, I used the mockup utils to load those authors and books. And I create a list of books at the end. This is nothing special. Then we already added something. It's always the same. Add something to a collection and store the collection. We already talked about this. Nothing special. Create a single one. I would say it's mostly the same. Creating one, and that's okay. Nothing special. Get books, also the same. So that means this is the CRUD, the C of CRUD as creating stuff. Now, this could be interesting. So getting books with an A. That's always a question, how to get data out of EclipseStore. And we come to that a little bit later when we talk about Streams API. But that's a good point. I want to ask you, who is working with Streams so far, or who works with Streams or ever worked with Streams? Sometimes, okay. Often, yeah, I would expect that most of the Java developers use Java Streams, of course, yeah. I think the point is, I asked those questions 2 years ago, and there are a lot of people are not using Streams. So, but for now, I think most of you are familiar with Java Streams API. But I think sometimes it's interesting to know. Okay, so in that case, we use the Streams API. That you all the time see this on that word stream. And as you see here, we go to the books collection and we stream through the books collection. And then we say, okay, we need to filter something. And in that case, we filter the books by name, and we want to have every book starts with an A. So this is this is the filter condition. And after that, we say, okay, please return a collection, or please return the result as a collection, as a list. And this is what the stream says. And yeah, that's how it works. Get books with an A, starts with an A. We could do this, we could call this later on. This is how to stream, but we talk about this in more detail later. Okay, now it comes to the clear section. So there was one question about deleting those stuff. Deleting stuff is also quite easy, and you have to clear the book collection. This is a normal Java method. And after that, you store the collection. That's all. So the point is what happens in the background. Whenever you delete something, you delete stuff directly from the RAM, right? So you clear the books collection, then that collection is empty. In the background, there is one process within EclipseStore. We call it housekeeping, and this process takes care about deleting stuff later on, or clearing without blocking the access of your storage, right? So that means you clear the collection, and after that, the housekeeping takes care about deleting stuff out of your Eclipse storage itself. There is more details about to know to handle those housekeeping processes, and you will be able to configure those housekeeping stuff. But this is too extended to have it here within the fundamental training. I think the important thing to know here is just clear your collection and store the collection, because the collection has changed, and that's all you have to know. Update a single book. To update one, we need to find one. That means in that specific case, I tried to, or I asked for the first book, and I changed the release date. And the point is, I changed the book. So the book itself is the reference holder of the released date. And therefore, we store the book itself. That means db storage manager.store book. That's it. Really straightforward. Nothing special. How does it work in the background? What happens on the storage side? Well, the point is, when you store or when you change something, as I said, it will be attached to the end of the storage every time. It doesn't matter if you delete something or update something or insert something, it will always attached to the end. Of course, except when you delete something, it has to be attached at the end. But when you store a book, for example, you attach a new version of that book at the end to the storage, and the housekeeping takes care about to delete the old version of the book out of the storage. So that's how it basically works. Book successfully updated. And here comes a special thing. Maybe you remember, I talked about that. There are possibilities to store a traversal way, I would say. So you will be able to create an eager storer or a lazy storer. Whenever you hand over something to the eager storer, it stores everything below the object you hand over to that method. So that means when you change the author of an object, for example, we have one book, starts with an A. Let's say that these are all books. We iterate through these books, and we change the price of the book, and then that's now I should explain it in a different way. So in that case, we use the eager storer as a transactional storage behavior, right? So that means we create a storer, then we change multiple books, and at the end we hand over those books to that storer. We call eager storer.store, and we yes, no, that's not what we want to do. Moment. Yes, no, B should be moment, big decimal, B get price. It should be B in that case. That makes more sense. Like this. So that means we change the book and we add the book to the eager storer, and at the end we call a commit method, and this commit leads that the changes are persistent on the storage side. It is definitely more faster than calling the store every time you change the book, because the store method is a blocking call, and because of that, it's definitely faster to do it this way. And especially when we talk about transaction, there is an embedded method to roll back those changes at the end. So that means whenever something goes wrong here, we could add a try catch This is also part of the advanced training. We could add a try catch and then doing a rollback on the object which has changed. So whenever something goes wrong, this is a transactional behavior. But instead of using the storage manager, the eager storer or lazy storer for those transactions, you could also use it to store objects traversely. So this is also one reason to use it this way. Okay, let me just check your questions. Why not parallel stream? Yeah, sometimes I'm a lazy guy, and it's easier for me to use the stream itself, especially when performance is not an issue. I use stream because it's okay. Sometimes when you use parallel stream, you always have to think about, is it okay to use it in parallel? Do we have to consider something? To use stream, sometimes it's much easier, especially when performance is not an issue. I think that's the point using stream. But if you're okay with that, you could also use parallel stream. Doesn't matter. Yeah, store B, I guess. Yeah. So that should be that should be the right way to do it. Okay. After that, we have to call es.commit, and that's it. Any questions so far to an example, to this example? Let's try it out, right? So let's see if it works. So we could use it the same way. Oh, that's the wrong object, wrong project. So clubs demo is the right one. So let me just refresh it. Okay, everything is in place. Let's go to the application class and let's say run as Java application. It should directly start up. Just what's wrong here? Okay, here we are. Localhost books. So you see that it's the same preview at the beginning. Let's say create. So remember those 1,000 books of that JSON file. So let's call create. Here we are. So call it again. Now you see that 1,000 books within our storage. Books with an A. Let me just check what was the starts with A. See, that is the less books in that case. And when we stop the application itself, you see on the left here, the data folder is created. Now we have multiple channels. This is what we configured, multiple channels, multiple threads to write down the data. And when we now restart the application and when we call, where's the browser? So let's start with books again. You see this is the startup. It needs a little bit longer because database needs startup time, but then at the end we are able to call this method multiple times, and it's really fast, a really fast access. Okay, so any questions from your side so far? Okay, so let me just introduce you a little bit to the Streams API, just to give you an idea how to get back the data out of EclipseStore. And therefore, I created one project. Oh, I have to share this with you. Just a second. Streams, here we are. Okay, this project is just a collection of different possibilities of strings of streams, and let's just go through those examples, especially for those of you who not used streams that often, just to give you an idea how it works. And after that, we move on a little bit deeper to the lazy stuff, because or the data models itself. Okay, so this is the book controller. Okay, this makes sense. We have to go through this, and we have the streams controller. Okay, here we are. How does the EclipseStore do equality to correctly save the same object? How does it do equality to save the same object? So, for example, to update a book. Oh, so this is what I explained this a little bit at the beginning of the training. So each binary, I call it each binary string, consists of an object type ID and an object ID. In the background, EclipseStore creates a unique object ID, which identifies this object. And this is how, EclipseStore uses the normal Java usage of finding objects, and it doesn't matter if you use a hash code or equals or stuff like that. You can use the normal Java stuff to equals objects. EclipseStore will do all the stuff in the background. So, and EclipseStore uses a special object ID to identify objects. But on the side, so that means you just operate on the RAM. So on your objects, that's totally okay, and EclipseStore will do the stuff in the background. Okay. Let's move on. Okay, I would start with the easy streaming stuff, especially when we use or when we want to have our for each loop. These are the easiest streams that you can use. An in stream, for example, in stream 1, 2, 3, 4, 5, and so on, and then you can do a for each thing. That means streams it is possible to go through a list of something, and in that specific case, we stream through a number of in-stream, or you can do stuff like that, an in-stream based on a range, 5 to 10, and then you say, okay, for each, and doing stuff like that. This easiest stuff to use a stream, to go through something. Same here, we have an array of numbers. Then I could go with streams of these numbers, and then say for each, or arrays.stream. All these methods are possible to stream through something. An object stream looks the same, so that's easy to say, okay, give me all the books, stream through the books of a collection. And after that, I'm able to say, okay, for each, let's go through each book and doing something which which each single book at the end. Three different interesting things, or four, I would say, are these four methods here. You will be able to transfer things to different structures. For example, here we have books, we stream through, and in the end we say to array. And this is especially, these four things are examples for, you always have to define at the end of the stream what is the return value. So that means it's every stream mostly starts with the keyword stream, and at the end you have to define what you want to get back from the stream. And in this specific case, we have a list of books here, we stream through, and we want to have an array back based on books, for example. It's the same here. We stream through a list of books, and after that, give me back a list of books. That makes not really sense, but it's only an example. This could make more sense to say, okay, stream through a list of books, and I want to get back a set of it. So it's possible. Streams API. I think that's the basic stuff on streams. We need a stream keyword here, and at the end we have to define what type of data do we want to have back. So a special thing is this one. We have cat, dog, mouse, and bird as a list, and with the stream we could say collect this, and there are many different collectors here, and there is one which do some joining stuff, and this returns a string at the end, and it joins the values with a comma at the end. Maybe it's interesting to know that these things are possible. Especially when there is only one return type, you could use these two methods, find any and find first. Let's say we stream through the books, and then we say find any. That will return the first book within this collection. And it's the same here, find first. It returns the first one of the collection. And now a good question to you, why do we have two methods of that? Find any and find first. Does it make sense to have that? That would be interesting. Do you know the differences between these two methods? And why do we need them? Yeah, that's right. So with parallel stream, it makes the differences. So when we use parallel stream with find any and with find first, you will get different results. So for example, when we stream through a list of books in parallel and we say find first, then it doesn't matter which thread finds the first book, it returns the first. But this will differ from a single stream or a normal stream to use the find first. In this case, it will really find the first one of the list, for example. So, and that makes the difference. Okay, there are some more really complicated things, I would say. Even me, I can't remember all that stuff. I always have to search for stuff like this. There are all the possibilities we have within SQL, for example. It's also possible within the Streams API. We could do some grouping stuff. We could do some summary and average and sorting and stuff like that. All that is possible also with streams. I don't want to get those detailed in that part because, yeah, as always, I have to look on my collection of different streams to find the right one, which is needed for the task I have to do. The interesting part starts here. So when we search for a different, or when we have to do some sorting stuff, but let me just start here. That makes more sense. especially when we search for something. It's always the same structure. We call the stream. In between the stream call and the collect call, we always have the filter. And the filter says, okay, give me a book or all books named equals Bangkok Dangerous. And so we could find first that would do the same, I would say. But in this case, we want a list of books contains or equals Bangkok Dangerous. Another point which is nice to know is the predicate functionality, especially when it gives you, in my opinion, it makes it more readable to have it this way. You will be able to create some predicates, look like this, and then you will be able to combine those predicates with an AND or an OR statement. In this case, I said the name predicate and the ISBN predicate, and at the end you will be able to add this predicate to your filter function, and you could use those predicates. That could be quite helpful, especially when it comes to more complex streams and searches and filters and so on. This predicates would help a lot. Okay. I think that's the most important things you have to know about streams. A stream consists always of a stream keyword, at the end a collector, and in between a filter statement. That's how it basically works. Especially when you use EclipseStore, you have to use the streams API. That's the only way to get the data back, and that's the reason why we talk about streams, especially with EclipseStore, because it's the only way to search for data within your object graph. Okay. But this is pure Java. This is nothing special. And I think now it's, let's talk about a data structure. This is always an important question. How the structure of EclipseStore differs to a relational database, and how to migrate data and so on. Let's talk about this. And this is really, really important, because in the past, it's mostly you created a data structure, especially in Java, which fits best to the database, right? So you choose a relational database or a NoSQL database, but the database forces you to create a specific data structure on your Java side, right? That's how it is. And this is totally different on EclipseStore. We said on EclipseStore, the only structure we need is the Java structure itself. There is no data model needed anymore on another side. So, and this forces you to think about your data model more than before, right? So, and therefore, it's important to know how to arrange your data within a data model. And there are some aspects I want to talk with you. And this brings me to a small presentation, just to give you an idea. Proper data structure. So let's say we are a book selling company with multiple bookstores. We are selling thousands of books a day to our customers. What most important nodes, or let's call it tables, do we need, and how the relations would look like? So give me some suggestions from your side. What domain objects do we need in that specific case? Any ideas from your side? We need book, a book object. That's great, of course. Author, right? Makes sense. Customer, order, okay. Invoice, yeah, definitely could make sense. In that specific case, I put order and invoice together because, yeah, it's a business stuff and thing. Store, it's a good point. So we need stores. And we need our company. So let me just share my objects with you. So it's our company, and our company has multiple books, authors, stores, customers, addresses, orders, and employees. Now the question is how to arrange them now. So this is the first point I want to explain when people ask for how to migrate from a relational database to an EclipseStore database. I would say mostly you can keep your entities or domain objects. You can keep it as they are. Some fields are no longer required, but mostly that's okay. But you have to rearrange them a little bit because the structure or the tree is different in some parts. So we have the My Company object on top, and with EclipseStore we call it, that's our root object, right? So our company is our root object. If you remember in the last 3 examples, we used the data root as root object, and it's data root. It's not really a business object. It's a technical object to have multiple content below the root object. In that case, we use the company itself. The company has, of course, an address, stores. Each store has books. Each book has an author, orders, and so on. Let me just open this. And this gives you an idea how to arrange your objects. So that's easy, right? So that's nothing special. We all knew this stuff. But one question is, what if we need a combo box of authors in the app? Let's jump into it. So let me just create some smaller examples for you for a better understanding. So okay, my company, where to start? So okay, we talked about that. We need a domain object book. The first thing which is important for me to talk about, what about identifier? So do we need primary keys and foreign keys with EclipseStore? That's also always a question. No, we don't. So we always need a business identifier. This could be an ISBN or an email address or stuff like that. But we don't need a primary key or a synthetical primary key to identify an object. Sometimes it is necessary because some of the objects are not, they don't have an identifier like this. One example would be, let's say we have orders and we have positions, right? Then the position itself doesn't have an identifier because the position ID is 1, 2, 3, and so on, but there is no special identifier. But this is only the case on a table-related database because all the positions are in one big table, and then you have to create an identifier. Within our tree, it's totally different because the identifier is the order on top. So that means the order object itself contains the positions itself. And then the position number becomes a unique number because the number 1 could only be once in one order, right? So that is totally different to the table approach, because we don't have a whole list of positions anymore. This is I think this is what the mindset is different on that case. That means when we talk about authors, for example, and that brings me to the example or to the question from the presentation, our book contains the author, but that means when we delete the last book of a specific author, we lose the author itself, right? Let's imagine we delete or we sell the last book from Stephen King, and we need a combo box with all the authors in it. Stephen King is lost in that case, because there is no book. We are not able to query that author anymore. And that brings me to the point I have to say, okay, then we have to do it like this. We have a book here. The book contains an author. And when we store books, when we store books, we said that books is part of store itself. Yeah, you see, here are the books. Books are part of the store. And at the end, we have a list of stores here, but we have a list of authors also here as a list, because it's because of our business needs. And that brings me to the point, when you create a data model within EclipseStore, it gives you the possibility to decide the structure based on your business needs, not on your database technical needs. And that's totally different. And sometimes this could be quite hard, because you always have to make a decision, okay, how to create my data structure that fits best to my business needs. And that brings you to the point, you have to think about, is this a collection which is highly frequented by read access, or is it highly frequented by write access? That's totally different. So, and that is different in comparison to relational databases, where it's always the same, creating tables, blah, blah, blah. But I give you an example. We have a situation where we have to store, let's say, 20 million rows a day. That means around, let me just think about thousands or 1,200 per second stores. How to handle that within a relational database? How would you do that? So people ask me, is it possible to do stuff like this within EclipseStore? Then I have to ask the same question again. Is it possible to do that within a relational database? Is it an easy way to handle this within a relational database, storing 1,100 objects per second within a relational database? I don't know. The question is, maybe it's possible. If the database is strong enough, you could store this within one table. But what about searching or getting back data from that? How to search through that huge amount or that huge table? How to handle this? That's a big issue. But it's a big issue on the relational side, and it's a big issue on EclipseStore side. So, but the point is that we are able to handle those accesses differently. So, but I come to that a little bit later when I show you an example how to handle data like this. Okay, so that means we decide the data structure based on our business needs. And when it comes to the question how to migrate data, it's always important to think about your structure and creating a new structure. And then it's easier just start your application with your JPA, application, create at the same time, create an embedded storage manager with a microstream storage, and then just move the objects with some migration logic in between. And this is how to move. Okay, but let's go back to this example here. A question to you. Does that mean that we have to store the authors twice? Is that Or does that doubles the amount of storage we need? We should not forget that everything which is stored to EclipseStore is in memory, right? So we need RAM for that. So, but when we have a collection of authors here, and each book has its own author, that doubles the data, right? Is that the case? What do you think? Yeah, that's right. It's only a reference. It's only a pointer. Of course, you have to deal with it within your business logic. When you, for example, when you delete an author, for example, and you don't need it anymore, you also have to delete it here. And it's the same on how about adding an author? You have to add it here, and you have to add it to the book. That are business needs, I would say. But the easy thing is when you change the author within a book, it automatically changes within that set here. And there are some big advantages handling objects directly, because all objects are references. And of course, the reference is available twice when we store it, but the data itself, it's only once. And this is also a big advantage, because when you think about application servers which accesses databases, they always have to query the data. And the more you have, the more concurrent user you have on an application server, the more data you have doubles your application server. And that is different on MicroStream. That is why EclipseStore applications are so lightweight at the end. But let's talk about this a little bit later. Okay, so we see we have to do some more decisions on the data model. Just a second, I have to open my script so that I don't lose the okay, we already talked about this, that we use the my company object as a root object, and therefore we carry the list of customers here, we carry the list of stores, and we carry the list of authors. Another question which is asked a lot is, how about indexes? And that brings me also to the example you remember of that 20 million books a day, for example. How about indexes? Does it make sense to have some indexes somewhere? That's easy. You might saw it before. You could do things like this. Instead of using a list, you could use a hash map. And this hash map enables you to create, this one is the interesting one, I would say. That hash map enables you to create an index of your own for example books. So let's say there is one string, and this string could be, let's say, the first 4 digits of the ISBN. And after that, you have a list of books which fits to that 4 digits of the ISBN. And this enables you to create your own data structure, your own indexes, which helps you a lot to handle your data. And especially when we talk about those 20 million books a day, this is a structure which is quite useful. There is another aspect, which is the lazy loading thing. And I don't want to talk about lazy for the moment, but this is the way how lazy works. That means whenever we start EclipseStore, it will load the whole data from the hard disk. That means when we have a database which consists of 8 gigabytes of data, when you start up the database, you have 8 gigabytes of data within the RAM. A little bit more than 8 gigabytes because you have to calculate all the references and so on. But basically, this is how it works. And with that lazy here, you have the possibility to say, okay, these lists of books should stay on the hard disk. I don't need it. I only need the index, because the index gives me the possibility to search for something. And when I find the right thing, then I will load the list of books which I'm interested in. And EclipseStore takes care about just loading these books when you access these books. And this gives you the possibility to store that 20 million books a day easily within your RAM, because most of the time the books stay on the hard disk. And this is 1,000 times better than storing everything to one big table, because you have to find a way to search for it. You can store it, of course, but writing SQL to get out this data in an efficient way, that turns you crazy, I would say. You need indexes and so on. That slows down the writing speed and so on. And this is much more efficient, because you will be able to search within the key and find the right book which is needed. You see, there are different the data types, or the data structure in EclipseStore is different in some parts, but quite useful to your business needs. And this is how you should create your object model to fits best to your business needs. Another aspect regarding the lazy loading stuff is the point we have to make a decision which is the main data which is used all the time. This is a point which is not necessarily not necessary with the relational databases, because you don't care about that, right? So you say, okay, this is the data, this is the database, that's it. But at the end, especially with EclipseStore, you have to decide which data makes sense to have it in memory, to provide it in a high-speed way, I would say, with high performance. And then you will need the RAM. And many people say in that moment, they said, okay, EclipseStore in memory database. Okay, that sounds interesting, of course, but it's what about terabytes of data? And I already mentioned that those terabytes of data are not the data you need all the time, and you have to make a decision of what data can stay on the hard disk, which is not needed anymore because it's archived data, or something else which is not needed all the time. And the point is to store terabytes of data. And this is what Marcus mentioned at the beginning. Why is EclipseStore that much cheaper than a normal database? You always have to calculate both sides, and that's a real difference, because when you want to have an enterprise database which carries about terabytes of data, this will be quite expensive, especially when you have some some managed database services on AWS or some. They are insane expensive. But okay, you need a database, you pay for that. On the other side, you have an application server. And the more concurrent user you have on that application server, the more data you have to handle on your application server. That means the data has to be in memory anyway. So that means, let's say 100 concurrent user calls a query for give me some user, all the users, or give me a list of users. Then you have in normal things, because you will get object copies at the end via the SQL, and then you have 100 lists of users. Thanks God, caching comes with Hibernate, and that gives you the possibility to cache the data. But as I said, the more users you have, concurrent users have, the more RAM you need. And now when you have a look to EclipseStore, you will see that you have to count both sides. You have to count the database side, and then you have to count the application server side. And then you will see it doesn't matter if you separate the RAM of both systems, or you put enough RAM to one system to use EclipseStore as a storage, it's totally the same. At the end, and if there are some data which is only archived data, write it to AWS S3 as a blob storage. So nobody cares about storing data on a hard disk, but you don't need a database for this. Why to use it? You will be able to search through AWS also. So don't need a database system for archive data anymore. Okay, many different aspects. I could talk about this the whole night long, I would say, but that is not the case. I think the biggest or the best message is please take care about your data model. Choose the right data model for your business needs, and think about the different possibilities of Java. There are a lot of different collections and stuff like that, and points to create a really powerful object model and use it within EclipseStore. I think that's the most important point I want to say when we talk about an object model. Especially the usage of hash maps. They are quite powerful. So you have to think about that. Okay, last but not least, there is one topic to talk about a little bit more in detail. It's the lazy topic, and I just want to do a short step into it because it's important to know that there is a possibility to keep data on the hard disk. And give me just a second. This is a little bit more in detail explained in the advanced training, but just to give you an idea how it works on EclipseStore when you start creating a project. Okay, let me share that project with you. That's always important. This is a project I created just to give you an idea how lazy loading works in the background, and especially on the advanced training. I used the visual VM tool to show or to give you the evidence to show you that the data stays on the hard disk as long as you need it and so on. And this is the link to the project, Lazy Demo. There are, as always, several branches in it: change to lazy, change to map, multi-maps. And yeah, I come to that a little bit later. Why lazy references are important. As I mentioned, EclipseStore is an in-memory database framework. That is one reason why it's so fast and performant. Of course it is. So this is best performance you will get when the data is in the RAM. This is what we talk about. As I said, it's not always recommended to have data always in the RAM, especially when we talk about blob storages and stuff like that. So, or when it comes to binary data. So nobody would want to have binary data within the RAM all the time because it's not needed all the time. Yeah, and sometimes it's just unnecessary to hold data inside the RAM. It's not possible. So that means we need a possibility to decide which data do we have within the RAM and which data stays on the hard disk. The default behavior is what we see here. So when we have an object model, which looks like this in a way, and let's talk about 100 million objects, then you will have 100 million objects within the RAM. If you provide enough RAM and it makes sense to you to have these objects like this, then you're good to go. So use it this way. But this is mostly not the point. So, and this is mostly not what we need. And that means when we use lazy references on specific points on the data model, that enables you to say, okay, let's put a lazy point here and here and here. And after that, it looks like when you start up the application itself, it looks like this. You will only get access, well, and this is wrong, I would say, because the 2 here is also lazy. I have to correct that. That's also lazy. So that means everything below that lazy reference stays on the hard disk, and this enables you to create certain steps within your graph, and you can all the time move a step further. For example, let's say we have an object size which consists of, let's say, I don't know, 100 fields, for example. Why not to create 2 objects, one with the most important values of a person, for example, so the most 5 searchable fields, and then we have a detail object, which is a lazy one, and it's only loaded when you need it. So we are totally okay with that. Nobody would always call the details of a person. Mostly you want to see the most important data on a list, for example, to search within or something like that. Put the other data or keep it on the hard disk, because this is data which is not needed all the time. Okay, this is how lazy basically works. Just a short explanation when to use lazy loading. It's kind of like a best practice we would recommend. Always on binary data, blobs, documents, images, and always on huge collection with less frequent data. That's what I talk about, archive data, logs, and so on. And sometimes on collection with huge amount of sub-entities. So when we talk about entities within that collection with many fields or some binary object fields in it or whatever else. So, use it whenever you want. If performance isn't that important in this part of data model, the amount of RAM is limited. So that's also, if you have to take care about RAM, then you have to use lazy loading at the end. The first point here, the binary data point, is also a very interesting point. In my personal opinion, I would never recommend to store binary objects in a database anymore, because nowadays it's much better to use any binary storage, and that gives you another huge benefit. When you access binary objects through your own database, you always have to transfer those binaries through your application server. When you use binary storages, that traffic you can reference directly to that storage, and then the traffic did not go through your application server. But that's another aspect. So okay, let's move on. How to use it for a binary data, for example, could look like this. So this could be one possibility. Especially that we have a byte array here. So for an image, let's say there is one image per book, then this makes sense. We would search for a specific book, and then we could load the image. But what about if we have multiple byte arrays within a book, for example? Then we need something to search for, and therefore I would recommend to use a hash map. To have a key to search within that key, and at the end we have bytes here, and we can open that. We can say, okay, give me the elements. Next one. Let me just have a short look. Lazy list of books. That's a good possibility to have it this way. Yeah, here we go. You always have to consider that when you use a collection like this, list of books, and you put it to a lazy reference, or you handle it as a lazy reference, when you want to search within that list, you have to load the list. That means this solution or an implementation like this is, I would only recommend for smaller lists or for a list with small amount of or with smaller objects in it, for example, because the list has to be loaded at once to search within, and that doesn't make sense because let's say there are a lot of concurrent user which accesses a list like this, then it makes no sense to have it in a lazy way because the list is entered anyway. So, and it stays within the RAM because everyone wants to access that list. So it could be a list of users or admin users of an application which is only accessed by the application administrators, for example, kind of like this. A better solution is this one. We already talked about this usage of hash map. Oh, sorry, create an index for some books, for example, that could help to handle a huge amount of data. And there are many more possibilities to use that lazy stuff, but I will get in details to that in the advanced training, just to give you an idea now how to handle that. And by the way, there are some adjustments or configurations you could do when it comes to clear those lazy references. That means you will be all the time able to clear a lazy reference when you call the clear method that clears the data or that that marks the loaded elements as cleared, and that enables the garbage collection to clean it from the RAM. That's one. And this is the reason why I call the system.garbage collection, but this is not the best practice part. You shouldn't do that. It's just to give you an idea that to clear lazy images marks the loaded entities as clear it or clean it. But there is another possibility to handle this in an automatic way. That means when an object stays untouched for 30 minutes, then it will be cleared automatically. Or when you reach a memory quota of 75%, for example, then the lazy stuff will be cleared at the end. Cool. But let's talk about this within the advanced training. Okay, so that was the topics from my side. Any questions from you? I think that was enormous informations within that 4 hours, but ask if there are some questions. No questions. Yeah, when you set the books, you have to create the indexes. Yes, you are right. Let's give me just a second. Then I'm able to give you an idea how this could work. Oh, that's the wrong project. Streams. Here we are. Lazy. Switch to multi-maps. Let's go to this and domain persons. Yeah, this is a nice example and an extended example, I would say. you could have multiple persons with different indexes in the same application. So one possibility to have persons by last name as an index, persons by mail, or persons by ID. As I said, it's just an example. It always have to fit to your business needs, but this is basically possible. And whenever we add something, we have to take care about creating our own index. And this is what happened here. For example, we use the compute if absent method, and we say p.getMail substring. That means we use the first 2 digits of the email address as an index here in that map. And this is how we create those indexes within a map. I would say it's not that difficult to do that. But yeah, an index could also consist of a comma separated values by, let's say, first name, last name, email address, and something else. And that enables you to search within and to get the right person, for example. Everything is possible. It only has to fit to your business needs. Okay, some more questions. So we have 8:45, so 8:45. That means 50 minutes left. If I want to store all file of a project, gives me to save it in one step. So you mean you added multiple objects to a collection, right? And you want to store it all at once? Is that what you need? No. Okay. Just a second. I hope I understand what you need. So stuff like this one, so that we change multiple objects and we want to store not every object instead of storing all at once. Is that the better example, what you mean? Oh, okay. If I want to store all files of a project. Then I'm afraid I need a little bit more. One step. Oh, sorry, I'm quite confused now. No, which IDE? What do you mean? Okay, I don't get it. Sorry. If I want to share to a colleague. Okay. A project itself. Okay. I would recommend to use a Git in that case. So use Git. Just share the link I've shared with you, and he is able to check out the same project. Okay. So it's not an EclipseStore related question. Okay, sorry. That's sometimes. Okay, so if you have no further questions, I would say thank you. Attend the training today. For me, it was a great pleasure. Hopefully, it was not that boring, not that boring for you. Try it out. It's a different mindset, I would say, but it is worth to do it like this. Feel free to attend to the advanced training. I really recommend that trainings too, especially if you want to start the production in a production way of using EclipseStore. There are many best practices and stuff like that within the advanced training. So please, yeah, take part on that advanced trainings. That will help you a lot. And yeah, I would say thank you and have a nice evening or a nice week, and thank you. There is no specific feedback form for now. If there are some suggestions from your side, just send me an email. Let me share my email address with you. Let's see. That's close to .1. If there are any questions from your side, some specific question or some suggestions or some things you want to improve within the training, let me know. Send me an email. Oh, sorry, I shared it directly with Mohammed, but I want to share with all of you. This is my email address. Let me know if something is wrong with EclipseStore, if you need some more help. And otherwise, you could use the GitHub discussions to send us some bugs and hot fixes and or stuff like that. So that's it. Okay, so thank you very much. Enjoy. Nice to have you in my training. The upcoming workshop sessions are advanced and advanced 2. The topics are, I would say, totally different, more extended, more in detail, more best practice parts. These are topics especially for people who want to start with EclipseStore and creating a project based on EclipseStore. Yeah, really helpful, I would say. So one thing for the people who are still there, regarding the certificate, when you I will add your email addresses to our system in the background. And when you join our EclipseStore or MicroStream cloud application, you will find your certificate within your account. And important is you have to register with the same email address which is used to take part on the training. Then that fits together, and you will see your certificate at the end within that cloud backend.